you want to go grab it.
This meeting is being recorded.
Wow. Okay, so if everybody who's not speaking could go ahead and mute yourselves, that'll be helpful, and we'll get going. I am, and again, really happy to see you all. And we're kicking off this fall conference with a fundamental session. And joining me in this presentation is Maura Hawkins. Maura, as you may know, has been a planner for a long time. She's got a lot of experience. She's also been doing something really important to me, and I think for our new planners. She's been one of our guest presenters at the Toxic Use Reduction Planner certification course, and she talks about process characterization. And so, Maura, I'm really grateful that you're here. You've always been just so enthusiastic about this topic, and that's important to me as we talk about what is such a fundamental part of toxic use reduction planning. So what we're going to do, let's see. Now I can, there we go. So what we're going to do is I'm going to talk about sort of the regulatory requirements associated with process characterization, the theory of it, you know, what you're supposed to do, what the guidance says, sort of, you know, the book side of it. And then Maura's going to be jumping in and talking about what she's seen in practice, and what she's learned are really best practices to get the most out of process characterization. There's going to be plenty of time for conversation, and we're going to be breaking into small breakout groups. And you know, the idea is for all of you to have a chance to share your thoughts, your questions, your ideas, your best practices in those breakout sessions. So any questions before we get going? One thing that I didn't do this time around is the whole, like, how to use Zoom stuff. We've been doing this enough together at this point. I'm assuming you all know how to do it. If you have a question, please go ahead and put it in the chat. Liz is here and monitoring that for me. Thank you, Liz. And, you know, Liz, if there's a question that you want to break in, you know, to the conversation to share, please do that. This is going to be fairly informal, but off we go. So I wanted to start by showing you this graphic. This is something that we use in the training for new planners. And the whole concept is that toxic use reduction planning is not a linear action. It's not something where you start at point A and go to point Z and call it done. It's a continual improvement process. Some of you may feel like it's a never-ending cycle. It really ought to be a fairly never-ending cycle. You know, it should be something that is there for us to continually be thinking about. But as you know, it's every 2 years that you need to go ahead and you know, prepare a plan. Process characterization is the foundation of the whole process, basically. It is the way that we understand why we're using toxic chemicals, where we're using them, where our opportunities are. The better you can characterize your process, the more likely you will be to really identify valuable opportunities. So it's a production unit level process, or part of the toxic use reduction planning process. So it's really focused on your production unit level uses of toxic chemicals. If you have more than one toxic chemical, you should have more than one process characterization action that's part of your planning process. It's really about, you know, what you're creating, where the chemicals are flowing through the process, what purpose they serve, and then mapping that out so that you can have a visual cue to help you identify where there may be opportunities for improvement, opportunities for reduction. So great. I'll touch on other aspects of process characterization, which are materials accounting and cost of toxics. Those are all part of the process characterization.
What is it?
But we're not going to get into too much detail. We've had other sessions really diving into materials accounting more. We've had sessions of diving into the economic evaluation and the cost of toxic side of things more. So we're not going to focus too much on that. We're going to instead focus more on these first two items, the description of your production unit and process mapping. As you go, you may notice that I've been muting people as they join, and I just do that to try to minimize any distractions. So, process characterization. This is what we teach our new planners and kind of tell them about why process characterization matters. I mean, it helps us to pinpoint where the wastes that may be generated in your process are originating. It really helps you to identify what the true cost of using toxic chemicals is. And that's very important when it comes to evaluating the economic feasibility of switching to a different alternative or switching or changing your process. So the process characterization piece can really help in highlighting what those true costs might be. As I said, it helps us to identify our toxic use reduction opportunities, and it provides a basic unit of analysis for toxic use reduction. And that unit of analysis is unit of product. So those are kind of the theory points around what's important about process characterization. Maura has some other thoughts on that. Maura, if you could go ahead and
Sure.
share your screen. There you go.
Good morning, everybody. Thanks for giving me an opportunity, Pam, to help here. So why do process characterization? This is something that I do. I'm a general practice terp and go to a lot of different plants. And I just found that this process is probably the most important part of the whole Torah thing. So the first thing that I think it's valuable is that you learn a whole lot about something. I mean, often when I step into a facility, I don't necessarily know everything. Even if you are an ops manager or a person in the plant, you might not know everything that happens. So I think it's a great opportunity to learn a whole lot about the process and the individual steps. Secondly, I get to ask a bunch of questions. I am curious by nature, but it's how I learn. And it's really a good thing for me to go around and ask a bunch of questions. Where does this come from? Where does that go to? Why do you do this? How does that work? Those kind of questions generate solutions for me or understanding of a process. So I appreciate the opportunity to do that. It helps me to get my head around what's really going on. Sometimes you have the really, really big picture. You know that something comes in and something goes out, but you want to have a really good sense of how the material flows around the plant, where things are added, where they're taken out. It's super helpful for me to do the process characterization part. As Pam said, it sets the fundamental base for everything else you do for Torah planning. I find it hard not to go forward in the whole Torah planning process if I don't understand the process characterization well enough. Because invariably I'll get to a point and I'll go, well, wait a minute, where does that come from? And I'll have to go back and figure that out. For me, it gives me credibility with the plant, with the facility. Sometimes I'm a terp, I'm doing everything from the beginning to the end. Sometimes I'm just part of what's going on. I'm obviously not there all year round while they're trying to figure things out. And sometimes on a few occasions, I'm simply reviewing a plan that somebody else has done and I'm helping them understand it. So the process characterization, please, it just gives me credibility so that I actually know what I'm talking about instead of just coming in and saying something that's not relevant to the plant. Next slide. Yeah. The process characterization step, it helps to see the plant in a different way. For me, it does. I get to go onto the floor when I do a process characterization. As I said, I look to see where stuff is coming in, where it's going out. You're looking at actual transfer of product. You're looking at what the operators are doing, what the operators are wearing, how they're managing it. It just gives me an opportunity to see the facility and the plant in a different way. Process characterization gives me an opportunity to talk to people on the floor or talk to people that are managers. Everybody has a role and they have insight, and some of the most important information you get from talking to somebody on the floor that says, hey, you know, we used to do it this way, but I really thought this was a better idea. And so it's an important opportunity for me to do that. It gives you another opportunity to address other regulatory issues. I found that sometimes during the process characterization process, you realize that you might have an air emission in a location that you didn't otherwise have, or you might have an opportunity to control an emission that you didn't otherwise know that you had. Like, why don't we just put it here and then we won't have an air emission, or wastewater, that kind of thing. And most importantly, it gets you away from your desk, because we spend a lot of time at our desk, and I would rather not be at my desk so often. Okay.
Thanks, Maura.
Yep.
So I'm going to talk a bit now about the regulations, the regulatory requirements, and we'll take it from there. So it is, as I said, a production unit level aspect of toxics use reduction planning. You'll find it at 310 CMR 50.44. That's where the process characterization piece resides in the regulations. And for each covered toxic chemical, and a covered toxic chemical is a chemical that you have to do reporting for because you have exceeded a reporting threshold, right? So for each covered toxic chemical in each production unit, you need to provide in your plan a description of the specific purpose of the chemical. And in the guidance document, it actually encourages you to really think about the function that it serves and to provide that in your plan. You need to identify the unit of product, which is a metric that we use for measuring your success in reducing toxic chemicals. And we're going to talk about that some more. You need to provide a process flow diagram. It's a required element of the toxic use reduction plan. And we're going to spend quite a bit of time looking at a variety of process flow diagrams and talking about what needs to be there, and how do you make the decision to create a flow diagram that looks the way it does. Other aspects of process characterization at the production unit level include material accounting, and this includes both use, byproduct, transfer, and release of your covered toxics throughout your facility, throughout your production unit. And then finally, you need to provide the cost of toxics, the cost for using the toxic chemical that you're looking for a way to reduce. And within the regulation and within the guidance, it talks about how you can either have a quantitative cost of toxics or a qualitative cost of toxics. So these are the required elements of process characterization within your toxics use reduction plan. So the production unit, again, it's a production unit level requirement. What's a production unit? It is that process, line, method, activity, or technique, or a combination or series of those elements that you use to make a product. So here we have a very simple block diagram of an etching process. You can see that there are blocks for the 4 main steps within the production unit. You can see that it looks like there's something coming into that from a different production unit, and something that whatever's leaving this production unit goes on to another. You can see that there are chemicals being added to certain blocks, certain aspects of the process, and you can see some release. So the production unit itself is considered a distinct entity within your toxics use reduction planning for this hypothetical, it looks like there's at least 3 production units that would need to have all of the elements laid out for it. But again, process characterization is a production unit level activity within toxic use reduction planning. So unit of product. Unit of product is an important aspect of what we do, right? It's that metric that we use to measure how much toxic use reduction we're achieving. It needs to be the same as the unit of product that you are using in your Form S reporting every year. It helps, again, it helps you to really assess how effective you're being at reducing your use of toxic chemicals. And it normalizes data so that regardless of how production may be fluctuating over time, you're still able to compare sort of a apples to apples level. If you have a sudden increase in production and your raw use of toxic chemicals goes up, you may still be able to you will still be able to see that you're achieving toxic use reduction if you're able to report your information, your use of chemicals on a per unit of product basis. And so a lot of the reporting and a lot of the planning talks about what is the total amount of chemical used or in byproduct, and what is the amount per unit of product. And it's important that anybody who is doing toxic use reduction planning is really thinking about that per unit of product level aspect of their work. And it's not always easy. In our class, we talk about a number of different scenarios and what are the best units of product. It can be quite challenging sometimes. And so what I wanted to do now is to break us into breakout groups, and I'm going to make them small enough so that that everybody has a chance to really, kind of share their thoughts on examples of when you have seen a process either in your own facility or in a facility that you have done work with that was complex enough that there was some question around what would be the best unit of product. So just talk about what is that kind of process? What did you think about? What did you end up choosing and why? And then when we come back, I may ask for a few folks to just say what they've heard. Maybe Liz and Maura, depending on what breakout groups you're in, you can kind of pull that back. But what I'd like is for each of the breakout groups, and there's going to be 15 breakout groups. If you could have one person just share, kind of one example. The process was this, and we chose this unit of product, and this is why. So it's a 10-minute conversation. It's a time for you all to share what you've been doing. And this seems like a very simple aspect of toxic use reduction planning, but in fact, I think it can be quite challenging. So I'll be interested to hear what you talk about and what complex processes you have identified or talked about together. So I'm going to share, I'm going to send you off into your breakout rooms, and I will give you a minute notice for when you'll be coming back, but have a good conversation. I'll see you in a bit. Open all rooms. Okay. Go ahead and join your breakout rooms. Doug, are you able to join your breakout room? Yeah. Julie, have you been able to join your breakout room? And Ken, if you could go ahead and join your breakout room. Tamara, have you been able to resolve your issues there? Boy, if you're talking, I can't hear you. Go ahead and join your breakout room. Julie, go ahead and join your breakout room, please.
Images and
This
such
meeting
like
is being
that. So it's hard to lower. We can't control those things. The amounts are regulated. We build parking garages as well, and those are also regulated, mixed design. So it's difficult. We've tried some things, but the stuff, the product has to be in what we use.
Right. So
Um,
when you're doing your planning, Jody, do you use pounds of
Yes,
mix?
yeah, it's pounds. It's yards in a truck, but we calculate everything out in pounds. The good thing is each year it changes. So last year we didn't have to, we were below the permissible limits for our mercury, which was good.
Yeah.
So we didn't have to file, but it depends on where we're getting our cement and fly ash from. And the CNI is something that has to go into the mix. There's really no other chemical other than a vendor to change. It's part of the design.
Wow. Yeah. Yeah. Challenging. And thank you, Jody.
Yeah.
Anybody else want to share a complex process, unit of product?
It's not too complex. We have a manufacturing line that produces a fiberglass sheet for AGM batteries. Our unit of product is pounds, and the the toxic that we use is also measured in pounds, so it's pounds per pound. The other one we spoke about, another process in tape manufacturing, was used for a coating, which was a solvent. And I believe the unit was area. I'm not sure. I don't remember if it was square yards or square feet, but it was an area unit of product. And I'm guessing the pounds on the toxic as well.
Well, certainly you have to report on your pounds used. So it would be pounds per square foot in that, or square, whatever, area. Yeah. Interesting. Good. Any other kind of unique examples anyone wants to share?
I was,
Whoops, go ahead.
oh, it's okay. Go ahead, please.
Who's speaking?
Well, Sandra, you're speaking.
All right. So I drove Susie Peck crazy over the years with my unit of products because I have a unit of product. Can everyone hear me okay?
We can.
I've been having
Yes.
computer issues, so I'm sort of in a jury-rigged system here this morning. So I started out, and I did a lot of statistical process control before I became a tour planner. So I know how to use statistics to find variables and processes that relate to one another, so that when you're setting up control systems, you pick the elegant solution, as was taught to me by my Finnish engineers that I worked with. And what you do is you model a process statistically, and you look at all different kinds of variables as far as their relationship to one another. And eventually what floats to the top is the one or two parameters, what they call the elegant solution. You find the ones that are key for controlling the process. So I figured, well, if it was good enough for process control, maybe I can apply this to the toxic use reduction unit of product conundrum, because going around to the different places, it's a variety of processes I've been involved with. And the metal finishers were a real challenge, because they do variety of parts and shapes and sizes and weights. And so I did a variety of modeling with the metal finishing clients I had, and I came up with, anybody want to take a guess what the unit of product was?
Dollars.
No, we did model that though, and it was not the best relationship, but we did take that as a one to try. Anybody have any other guesses for a metal finishing shop?
Square footage on sales dollars?
No, we didn't touch that, because the parts were all really variable. Pardon me?
Was it water?
Yes, it was water. Very good. Ding, 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 ding. And that was the one that touched all the parts and ended up being the best correlation. Now, I did do a presentation a while back ago. You can find it somewhere on the Turi website it was a resource conservation project for doing coating and using the solvents evaporated that went to the oxidizer and capturing the heat from the combustion, the heat of combustion from burning the solvents, and recycling them back into the dryer. We were working to find a unit of product for their TUR plan. And it turned out to be another really crazy unit of product that emerged after doing the statistical analysis. And it ended up being heating degree days, believe it or not, because the natural gas that was used at that site was used for space heating, as well as to supply heat to the oxidizer to burn the VOCs. But when you put a heat recovery oxidizer on the back end of the process, what happens is you need very little natural gas from the utility to burn the VOCs once the heat recovery oxidizer gets up and running. And it was the natural gas that was being used at the site, it turned out, was being essentially only used for space heating within the facility. And that was the strongest correlation. So we went to heating degree days, because the relationship between heating degree days and natural gas use is, it was like a 0.8, 0.9 correlation, which means 80 or 90% of the time they relate. So we went with that. And plus, I've been doing it for 30 years in my house. I convert all my energy to BTUs, and it relates to heating degree days. I actually have a graph for the last 30 years.
Thanks, Sandra. Yeah, I bet you did drive her crazy, but you know what? That's a good thing. Listen, I'm going to keep going with our presentation now, just in the service of time. So I'm going to share my screen again. So that's really great, really good conversations. It's an important aspect of process characterization. One of the questions that we've had in class over the years has been, what happens when you decide that the unit of product that you had been using is no longer your best option? And so that's something that you need to think about. And if anybody wants to share in the chat, like what you would recommend, I think that would be really helpful. I'm going to move on though, because I really want to get through the rest of sort of the important aspects of this. And the next really important aspect of process characterization is materials accounting. And I'm not going to do more with it than to talk about what is required in the regulations. You are required to describe where you're getting the data that you're using and how you're determining the amounts that you're reporting and any assumptions that you may be making. So you may be getting your data from direct measurements, which is always great and preferred, and not always possible, right? Particularly when you're talking about a production unit tracking of materials. So you may be doing estimations, and how are you doing that estimation? Are you instead using engineering calculations? You need to, within your plan, describe where you're getting your data and how you're determining the amounts that you need to report and any assumptions that you make. And it's really important that that documentation is maintained in your plan so that should you leave the facility and somebody else take over, they need to be able to understand what you did and why you did it and present that in case the Department of Environmental Protection wants to understand. If they have any questions moving forward, whomever is the planner needs to be able to respond. So documenting what you've done and describing where you're getting your data, how you're assessing it, and any assumptions you're making is so important. So, key for process characterization. Again, you need to talk about both byproducts and emissions from all portions of materials handling, as well as what you're using in your production unit, as well as any transfer and storage of final product. So if there's any byproduct or emissions associated with any of those steps within your process, they need to be accounted for in your material accounting. Byproduct generation needs to be allocated between production units if your covered toxic chemical is used in more than one production unit. And so that really points to making sure that you're understanding your numbers and your chemical pathway throughout each of your production units, so that you can do them. And your materials accounting has to be revised for each plan update and of course for every Form S. Materials accounting, that aspect of it gives you really important information that allows you to determine the full cost of toxics for each covered toxic. So material accounting, super important. And those are the kind of the elements. Again, I really want to point people to the guidance if they have any questions. And maybe Liz, you can throw up on the chat the link to the guidance document. Now let's talk about process flow diagrams. And so when Maura was talking about doing a walkthrough, it's about gathering information and making sure that you're understanding what's happening where. It's not an architectural drawing necessarily. It's a schematic. It's a depiction of the essential processes required to operate your facility, to manufacture your product. It doesn't necessarily tell you anything about the physical layout of the operations, though it could be based on that. And I'm going to just launch a really quick poll. And in this poll, I'm asking for your response on just when you have created a process flow diagram for the first time, how did you do it? So I'm going to launch the poll. If you could all just jump in and give me a response there. And if it's not something that I had in the poll options, you can click other and just say in the chat, what you have done to create your process flow diagrams. That would be really interesting to hear as well. So I'm going to give you just a little bit more time. It looks like most people are working from existing process flow plans, and that's great. That means that your facility had them either because there was already a planning process going on from which they had to create something or not. Lots of people looks like are starting from scratch. I'm going to give it just another minute. Remember that, I need to know that you're all kind of actively participating in each of our virtual sessions. So I'm looking for everybody to respond to this poll. Okay, so I'm just going to give it a couple more seconds. If you could go ahead and respond if you haven't already. All right. Good. All right. So, just sharing the results, it looks like, 36% start from scratch, 45% work from existing flow diagrams. Only 3% of you, 2 people, talked about using piping and instrumentation diagrams. 7 of you have worked from existing floor plans. And then there's some others. It looks like Sierra's put something in the chat about what she's done. There's 2 other people who clicked other. Go ahead and share in the chat what that is. I'm going to stop sharing and we're going to move on. Good. Okay. So process flow diagrams. These are block diagrams often. They are showing what's going into each process, what's coming out of each process. What comes out could be a waste, or it could be an output. It could be something that goes on to the next process, or it could be a final product. Here's some examples of inputs and outputs. Is there anything missing that you've seen in your practice? Oh, Maura, if there's anything there that you see that's missing?
Just that there's sometimes a consumption within the process, but it is an input and output, but in sometimes in the process there's a consumption.
Right, and that's absolutely true. And in the process flow diagram, you're not necessarily going to be depicting that. You will capture that. You need to capture that in your materials accounting, and certainly in your reporting. You need to be able to say, this is why I don't have a balance between my inputs and my outputs, because sometimes chemicals are consumed or are transformed, or are manufactured within the process. So that's absolutely true. So again, process flow diagrams, they're going to give you very explicit structure that you can use to help you identify points where you need to seek more data, and how you can translate that into something that's really useful for our toxic waste reduction planning purposes. And it's a way to help demonstrate, what your conclusions may have been. We can talk a little bit more about that, but the key factors of a process flow diagram, where the toxic chemicals enter and leave the process, and that includes your wastes, and it can include other aspects beyond just toxics. So I'm going to show you some examples. I think we've talked about these other elements. So this is something that I think is fun just to see, because it shows us how to do a process flow diagram for something we all understand, and that's laundry, right? So we know there's a washing machine, and we put our dirty clothes in there. What are some of the inputs for a washing machine? Just unmute yourself and shout it out. It's
Clothing.
Water and soap.
Yep. Electricity. Detergent, fabric softener, sometimes bleach, or there could be all kinds of things. And then what's coming out? Well, the wastewater, right? After you've done that. So and what else? Sometimes you might have like solids associated, and that's also maybe going to the wastewater. So lint from your clothes, which nobody wants to see, but it happens. Okay, now you can choose to use a gas or electric dryer, and then you're going to have other inputs, right? You're going to have what? You're going to have some sort of energy going in. You might be using something like dryer sheets, or if you're me, you're using wool balls. just to keep your clothes a little bit softer as they're going through this drying cycle. And then you're also going to have wastes. Definitely, here's where we see lint, but we also see heat coming off, and then whatever spent material you may be adding if you're doing that. So lots of inputs and outputs, and there is an alternative, right? You know, instead of using a gas or electric dryer, you could be using a clothesline. You know, and here we have inputs as well, and that would be, you know, sun and wind. And maybe you could also include labor if you wanted, if you felt that was important. But no real outputs associated with using a clothesline, right? I mean, you're going to have water dripping off, but it's going to go into the atmosphere. So I suppose that you could include that.
I would think you'd really have to include that. That's an emission.
Yep, that's true. And you know, it's interesting. We don't include. I don't show the water vapor with the gas or electric dryer either. But you're right. It would be with both, right? And so.
And the dryer would have lint coming out as a solid that would be in a filter, but it would also come out as an air emission.
Yeah. Yes. So this is great. This is why you guys are awesome, right? Because you look at something that we all know really well and you see what else there is to consider. In this example, what would the unit of product be?
Pounds of clothing clean.
Could be pounds of clean clothes. It could be
pounds of clean dry clothes, right? Yeah.
Could be, yeah.
Square yards of clothing.
It could be, you know, yeah.
In loads, basket loads.
What was that?
Sorry, measure in basket loads.
Basket loads, yeah.
And
Yeah.
you should probably measure from the beginning.
Laundry.
So I'm sorry, Sierra, what were you saying?
You probably should measure from the beginning because dirtier clothes are going to require most likely more chemicals to be cleaned. And you probably are also going to have at the end some laundry that has been damaged, and that's not going to go out to the customer. Those are going to be rejects. So those probably wouldn't be taken into account when you ship it out to your customer. So even though you're still going to clean it, it might not be a final product, but you would want to take that into account for your chemicals.
Mm-hmm. Unless your customer is your mom and she uses that damaged clothing to embarrass you every Christmas, which I do to my daughter.
Yep.
Great. So you guys are great. You just are showing how using something simple like this that we all know allows it sparks thoughts, it sparks deeper understanding what's going in, it sparks ideas around, well, maybe I should go back and measure this, or maybe I should rethink what my unit of product is. So you guys that's just a really great demonstration right there. I'm going to move on.
Can I interrupt real quickly and just mention that Sierra in her comment had mentioned existing process flow diagrams, but also floor plans. And we had a situation in the TR planner class this year where one group tried to draw the floor plan and draw the flows. And while that made it difficult to follow some of the chemicals, it actually also points out things like if your dryer is 2 buildings over from your washer. And you know, there might be other issues involved with that. So I just thought her comment about the floor plan is one that is good to think about when you're drawing a boxes based process flow diagram.
Yeah, so there's so much information that you can glean in this process, and creating a process flow diagram is just such a powerful tool in your toxic waste reduction planning process. This is the exemplar that's provided in the planning guidance document, and it's using different colors to show different chemical flows through the process. It's showing the product flow in yellow. It's got that green dashed line that is the production unit envelope, right? It's showing where the air emissions or the waste emissions are going and what's being done with them. It shows when it was revised. It shows what the the production unit number is. So this is just this is an example. We're going to see a lot more examples. That chemical pathway analysis, the chemical flow through your process, is a really important aspect of the process flow diagram. And so really getting clear on specific flows of toxics through your process, where there are wastes, which are byproducts or emissions throughout the process, is really important. And it can help you, as Maura mentioned, it can help you identify where there may be other regulatory issues that need to be considered. So here is a chemical pathway analysis for sodium hydroxide in a plating operation. And so we're just looking at one of the chemicals associated with this operation, and it's shown with that red arrow. So it's being stored somewhere and then delivered to a number of different steps within that process. And it's also going to the wastewater treatment facility on site. So this is using color to kind of make it very clear which chemical we're talking about. Obviously, in this plating process, there's going to be a number of different chemicals that really should be mapped through the operation itself. But you can look at this and you can say, well, so great. So the sodium hydroxide is going to the electro-clean. Is it not being carried over into the following rinse? Or is it being carried over into the following rinse? Should I be accounting for that? So you see what I'm saying? You can kind of look through each of the process steps and where a chemical is, and you can start to really question yourself. Am I accounting for every aspect of it? Do I have fugitive air emissions in any of these processes that I haven't already identified? So this is what we're using our process flow diagrams for. Here's another example. So this is a little bit more complex. This is showing that there are 3 different reportable toxic chemicals associated with this fabric coating process. This is the part of fabric coating where they're applying an adhesive to the fabric itself, to the textile. So you can see on the bottom, you've got the cotton fabric that's going through an adhesive roll coating process, going through drying, and then they're done. But the adhesive roll coating is using 3 different chemicals within that adhesive. The chemicals are coming separately, they're being stored and then blended, and then stored as a blended adhesive formulation and applied at the roll coating. So you can see kind of the inputs of those chemicals. Now we want to add a little bit more detail. What happens after that initial input? What happens at each stage? Are there wastes associated at any of those stages that we need to account for? And so you might be seeing that there's likely fugitive emissions in the blending process as well as byproduct. So that might be blended formulation that needs to be scraped out of the tank periodically or something, or perhaps blended formulation that isn't meeting specs and needs to be managed differently. You could also have waste associated with just the storage aspect itself, and emissions in the roll coating, certainly. Emissions from the drying, you would have fugitive emissions as well as those emissions that are being directed into the thermal oxidizer in this case, some sort of pollution control device. So you have both fugitive and captured air emissions, and how is that affecting the balance of chemical throughout the process? And then maybe you might also be having some fugitive emissions at the very end storage of the final product. So you see how we begin to build more and more detail and understanding of the process as we add additional information. We can look at another aspect of that same process, which is periodic cleaning. periodically we have to maintain and clean our process equipment. In this example, they're using one of their toxic chemicals as their cleaning agent. This is the MEK, and it's going into the blending and compounding vat to clean out that tank. It looks like it's also being used to clean the roll coating device. And it may also be used in the drying. I'm not quite sure why that might be, but there are byproducts associated at each of these stages as well. So it's another element of the toxic chemical use in this production unit. So if I combine all of that information together, we have a very full picture of what's happening. And yet, as you look at this, you may be seeing other examples where that chemical, one of the chemicals may also be released and it's not being shown there. There could be fugitive emissions at the adhesive storage stage, for instance, and it doesn't look like we've accounted for that there. Other aspects of what's in this diagram that we're looking at, you see these little codes, BB09 by the drying, GG04. These are those process codes that you are using when you're reporting. When you're reporting in your Form S, and when you're reporting for your plan, your toxic use reduction plan updates, you're talking about where and how is a chemical being used in the production unit. And these codes help to identify specific processes associated with your use or the byproduct of your toxic chemicals. This is all information that you can be including in your process flow diagram to help you make sure that you've got everything covered, and to help you identify where there may be additional areas that you want to check on, where there may be more information that you want to try to glean. So in your production unit, you want to show all the steps of each of the process throughout the production unit, show the points where toxics enter and leave. You want to make sure you're including the fate, and you want to make sure that you're including the production unit number. One of the requirements for toxic use reduction planning is that you update or revise your process flow diagram as needed. And so you need to document that. Documentation is an important part of toxic use reduction planning. Easiest way to do that, to document a revision, would be on your process flow diagram itself. If you think back to the exemplar that's in the guidance document, it had the revision date on it. So we really recommend that you include the date that the plan was created on the plan itself. You could have it elsewhere. You have to identify when an aspect of your plan was revised or updated. Might as well put it on that process flow diagram itself. Makes it easier for anybody who's looking at it to understand what you've got. So this, finally, I just want to show you that in the guidance documents itself, there is a checklist of all the items that are required to be in your physical plan. You all should know about this, and you should be using this each time you're doing planning. These are the aspects of the process characterization that are called out in this exhibit, in this checklist, with the regulatory citations. So it's everything we've talked about, and then the other things that we haven't talked about, the cost of toxics, etc. So this is in your guidance document itself. And with that, let's move on to more practical experience, and Maura, I'm going to let you take it from here.
Thank you. Appreciate that.
Yeah.
So this is just, I'm going to go over some things about how I go about doing a process characterization. And it starts with a understanding of the process and ends sort of with a description of the process, and it ends with the process flow diagram. So invariably, I'm a general terp, as I said, so I do some pre-site visit research. If it's a new facility, obviously, then I have to learn a different set of things. If it's an existing facility with an existing plan, or if I'm already familiar with the facility, I have some data available to me. So I do a little bit of reading. I check the website almost always of the plant, what their product is, what they're already doing, where their industry is. I do a little bit of research on the industry, understanding what practices are out there, what kind of equipment already exists, just so I can get my head around it. An image research so that I don't show up and look like I don't have any idea what I'm talking about, and understand what materials from the plant. I'll look at the previous reporting documents, obviously, any plans that already exist or permits that exist for air quality or wastewater discharge permit or something that already gives me some information on what we already know about. So before you even start, make sure that you have some background on it. This is what I do. The next thing I always do is I have an opening meeting with the relevant people. That might be the plant manager, it might be the production manager, it might be the ops manager, depending on how the plant is organized, the maintenance manager, or it might be I just start with the EHS manager and we just sit down and we talk about what the objectives are, not just the regulatory objectives of the plan, because that's the required component. But the whole idea of the toxic use reduction process is to make it relevant to the facility. And you have to kind of keep your balance on that all the time, not get too far over into the regulatory aspect of it. It's important, we have to meet all those things, but what's most important to a facility is the relevance to them, either for reducing the cost of toxics or reducing toxics in general or reducing the cost of it. So I try to ask for a verbal description of the process. It's better for me to have someone else do the talking because they know way more about it than I know about it. And ask some basic questions about what's the product, what's your actual product, how do you track this? Those things invariably just move along because, well, what kind of product you're talking about? Well, we have 5 products, well, we have 10 products. Well, how do we track those? How do we do? So those questions always lead you in different directions, but it's an opportunity for me to think about it, write some notes down while I'm talking and just get a better feel for the process. But it also gives me a better feel for the problems that they have themselves. They already know what their problems are. A plant already understands what their issues are, but by allowing them to talk and ask questions, I become more familiar with what their problems are and what the issues that they already have. And obviously invariably, you have to review the previous description in the plan. And I think this is not a step to overlook, especially on a renewal or an update to a plan. You do the best job you can on the previous planning cycle, but invariably there's going to be a change. So you want to go over that, make sure it's representative of what's still there, determine if any things have changed. Is this still the way it is? Did you guys have any operation changes? Did you do anything different? Do you have any new products? Those kind of things at the beginning of the process. Next slide.
I'm just going to break in. Bill, you still have your hand up. So do you have a quick question for us?
Actually, I do. Could you go back to the previous slide, please, just for a second? Maybe one. There you go, right there. Okay, so one thing that I do, which helps me make sure that I have everything in my tour plan that's required, is to. I mean, this is great because this kind of shows where everything comes from. But what I think is an easy process to do is you can download the PDF file, and these PDF files aren't protected. So it's easy just to select a bunch of text, copy it, paste it in an Excel spreadsheet, and you kind of get this look, right? Because it's actually going to have all the citations over to the left. So the right can be where in the tour plan is it located, what page, what section, which appendix. So then if you do this and do a checklist at the end when you're preparing your tour plan, you can just read through the actual regulations or requirements and out to the right, put where it is located in the tour plan, and that helps make sure you have all of the elements in the tour plan that are required and that you've addressed them. That's all I wanted to share.
That's great. Thank you. All right, Maura, go ahead.
So the next thing that you're doing, either while you're talking to the group or while you're talking to in your opening meeting, you're just writing things down. This is what I'm doing. I'm drawing pictures, writing down additional questions, not necessarily taking over the conversation, but just making sure that I write down, well, I don't understand what goes on here, what's exactly happened. And I try to get a basic block sketch of the process. If you already have a process flow diagram, obviously use that. You're not going to reinvent the wheel here. You're going to use that and make sure that you understand where things are going and that it's consistent with the tour form reporting. You might have already figured that out by doing some pre-review. And these are, again, some of the questions that you're asking. Where does the discharge go? Sometimes a process flow diagram might just show discharge. Okay, well, where does it go? Does it go to the POTW? Does it go directly to the POTW? Does it go to drums and then does it get settled and go somewhere else, or does it get stored in some area? And I think it's important just to make sure that you have full clarity on all those pieces. So at the process of doing the sketch and the understanding of the process characterization is an iterative process, as Pam said at the beginning. You're going over it, you're making some questions, you're going to circle back and ask those questions again. Oh, wait, I don't understand that. Are there any product losses? It's a good question. I'm sorry, Pam. That's all right. How does the operator know? I think, these are the questions you're writing down to yourself. Like, how does the operator know what he's doing there or she's doing there? Do they just make a decision? Is there a pH? What happens to off-spec product? So these are things that I'm doing when I'm first sitting down with people and understanding the process. Okay, thank you. You can move on. The next thing I do is a walk around. I start at the beginning of the process where the raw materials come in and proceed through the end. If you are in your own plant, sometimes it's good to have somebody else come with you. Then you're not doing it by yourself just because they might have a different perspective than you have. But certainly I've done it a lot on my own, depending on the plant. Identify all the points and steps where utilities, waters, fuels, etc., chemical storage and process material are entering or leaving the process. It's one thing to look at it on a process flow diagram. It's another thing to see it in person, where it actually comes in, how it gets in. Is there a port on the outside of the building where a truck drives up and you do bulk unloading? Is it coming in? Is there a hose that goes into a tank inside the building? Understanding all of those things and how they actually happen in the plant is important. You already know what to look for in general for byproduct and flow, but you're looking for fugitive point and area emissions to all media. I'm an air quality person from where I started, and that's my area of strength, but I'm always looking for fugitive points, point sources of emissions, any kind of a stack on the outside of a building. Well, where's that coming from? What is that venting? Or any kind of an area source of emissions that would not be a specific fugitive or point source. You're looking for byproduct flows to pollution control units. Is there any kind of scrubbers or any kind of wastewater treatment operations, on-site recycling, anything that would be capturing some kind of an emission that you want, or some kind of a discharge or byproduct from the process? You want to just, noting all these things, you might have to go back and figure it out later, but what is that doing? And then of course, you're looking for any leak spills, evaporative losses, maintenance activities. If you're looking on the ground, you're looking for staining, you're looking for spill kits, you're looking for, boom fabric, bermed areas, things that would indicate that there's some loss in the process somewhere along the way. So when you're walking around, you're looking for all of these things. Thanks, Pam. Next slide. Pay very close attention while you're doing the walk around. That's what I do, looking for how materials are being handled. Are the operators pumping it? Is there a pump or a meter there, but is it being used or not being used? Or is there a scoop? Is there a handle? Is there something, that kind of thing. You're looking at how many times materials are being handled. Sometimes on a process flow diagram, it goes into this process, but how many times does it have to be managed in order to get into that process? It may not be something that necessarily ends up on the process flow diagram, but it's something you want to understand because it helps you at the end. Like, well, couldn't we just make that more straightforward? Or why do you do it that way? More than that. You're looking for manual, automatic transfers, pumps, timers, regulators, monitors, anything that's indicating to you how that material is getting from point A to point B. Those are important things to look at. And whether or not they're being used. I think it's an interesting thing when you walk around a plant is that, yeah, we have one, but it's never calibrated, or, it's better for the operator. He knows exactly what he's doing, or she knows. So you're looking for raw materials and production, contamination issues, excess drums here, or some, waste piles of product. Not that you see it often, you're just kind of looking for those things. You're looking for open or closed vessels. containment areas, control devices. You're looking for things that where losses might be occurring that may not be intentional, but because of the way that the operations go about, it happens. You're looking for odors, visible emissions of vapors or not, because you don't want to take too big breathing exercises of breathing in vapors, but you're going to notice that when you're walking around the plant. It's just an important thing to say, where's that coming from? Labeling and signage, those are helpful things to avoid, watch for spills, slippery area, things like that, that might suggest there's something being lost in the process. And you're looking for people wearing safety equipment. I had a plant that people always wearing masks in this one area. And I'm like, what are you guys doing that? Oh, God, every time we open this thing, there's this big burst of powder that just goes blowing all over the place. I'm like, okay, well, that's an interesting thing. So you're looking for safety equipment. So it tells you when people are wearing safety equipment that there's a risk there of some chemical being released or something, something happening to a product. Thanks, Pam. So these are just some examples of things, anything you're looking at. Yeah, you all have millions more of these kind of things that you're looking at the plant. But I put this in here just to kind of give you a reminder of what we all do when you're walking around. You're looking at different things of what might look pretty good and what might not look so good. Staining on the floor, boom fabric around, that's kind of telling you something's leaking. There's, operators, things are kind of, there's backflow off the back of a spray booth, and, meters, are these working? Is the valve actually indicating any pressure or any flow? If you have a pump, is there a pump on it, or do you just not have one? And then, that's just people looking. So just you're looking at things. Yeah, thank you. I think the most important thing about the walk around for me, and I do it every year, even when I'm doing a renewal, just to make sure it gives me a grounding, a sanity check to make sure that I haven't missed something, or there might be a new operator or somebody there. But I'm just curious. It's not a time to point things out or bad. It's a time for me to learn what's happening there. And it's also a time for me the person that I'm with, if it's an operator or a plant person, for them to be curious and looking around as well. I really value the process of process characterization, just because it really, really allows me to be a toxic use reduction planner in coming up with options. Because if I don't understand this process and I don't understand the plant and what really happens, it's really, I'm not adding value in the way that I would like to. Ask questions about what you see and attempt to really, really understand the process. That's what my goal is. And my goal is to bring value to the plant. As I said at the beginning, it's not just regulatory requirement. It's, are you useful? Are you doing anything relevant to the process? Again, and at this point, you're not really trying to solve anything. You're just gathering data to understand it. I try to talk to operators, maintenance staff, INC techs, process engineers, and anybody that has some control or interest or some role in the process of chemical use in the facility. Good. Then the next thing you do, as Pam says, you're making a process flow diagram. You're using existing data. Obviously, you have even if you have a sketch that you've drawn yourself, you still might go back and look at operational data that already exists. I mean, there's some plants that I work with that are phenomenal amounts of data that they already have. They know exactly what happens in every step. Piping diagrams, they might help you if you're trying to solve something that you can't quite figure out how it gets from point A to point B. Operating manuals are also very useful about what do you actually do? Do you keep the lid closed? Do you keep it open? Does it have to be open? What do you do? There's workflow diagrams that often in plants that have how things move about in the plan. Architect's plan, honestly, I don't think I've looked at very many of those, but they do exist if you needed them. I think the most important thing is you don't reinvent the wheel. You're working off something that already exists in some fashion, or even if you have a sketch, you don't have to go retrace. You don't have to do it all from the beginning. Is what I'm saying. Okay, Pam, that's you, I think, right? Pam, is that you? You're muted.
Yep, this is your slide. I just made it look
You
different.
you made it look different. Okay.
Sorry.
Okay. All right. So go through, you're trying to get once you get to the point where you've done your walkthrough, you've had a meeting, you have to go back, and again, it's an iterative process. So you're going back and getting the details on the chemical volumes, the concentrations, the mixtures. There's a spreadsheet out there. I'm sure multiple spreadsheets out there that you're going to get. You're going to use those as they are, or you're going to reformat them into something that's useful for you. Make sure the calculations are good. I think this is an important step. Sometimes they're not, just the truth. They're missing things, or they're linked improperly, or something is not going right. Document how you came up with the numbers and look for consistency with reporting. Use actual measured data whenever you can. Pam mentioned it earlier. You have to document in your plan where your data are come from. I like to do that right on the spreadsheet. And if I have extra tabs of where the data sources, I just put those all in the spreadsheet, and then I link it. But in my final calcs, I'll put a note that, source data plant sheet on, production sheet, or plant production sheet this date 2021 or something. And if it's purchase records, I'll indicate that. But I like to do that right on the spreadsheet, so that it helps me, and then I can put that into my plan as an attachment, and I don't necessarily have to add additional text into the plan itself. So maintain a supporting spreadsheet of all calculations, obviously making sure those are good. And sometimes you have to you do have to take those and narrow them down and clean them up a little bit so that it's sort of easily presentable. The process flow diagram, I cultivate a good reviewer or two. This for me is also a great process. I had a new plant that I did this year that I hadn't done before, and we went back and forth, and it really ended up being a really great process. They had a flow diagram. I had some questions, marked up some things. Well, what happens here? I send it back to them. They go, I don't know what goes on there. They chase it. They send it back to you, and you're going back and forth. So it's really great to have a reviewer who can verify the numbers that you have on there and verify the process flow, because as a general terp, I'm not in the plant all the time. I'm not the expert. The plant people are. So it's really good to cultivate a good reviewer at the plant. And then, as everyone said, use the Mass DEP checklist. And I totally agree with Bill Judd's recommendation. We have that in a plan too. We just have a column that tells you exactly where it is in the plan, so you don't miss it. And I think whoever developed that original flow, that checklist was, thank you. That's what I have to say to you. Thank you for doing that, because it makes it easier when you develop the plan. It's all right there. Okay. So you sketch it out, use the process flow diagram sketch list. Okay, that's we've already got. Sorry, I probably should remove that slide.
It's all right.
All right, that's okay. So here's some examples. It's always risky putting up process flow diagrams of work that you've done, because invariably somebody finds an error. So if you see an error, just tell me in the chat or something, or send me an email and say, hey, you screwed this up. So these are all different. And that's the one thing I want to tell you, is that every plant has something different, because they look different. And sometimes this one, we were working off something they already had of a process schematic that was in their plant drawings. And it was like, that's pretty good. We'll just use that. So this is an example of a process flow diagram. It's just tracking the sulfuric acid and sodium hydroxide through the process. There's dates on here of the original date it was constructed and the renewal date. Data was updated, the process flow diagram. One thing I haven't done in the past is put on the actual process, those process codes. But I just started doing that. I haven't always done that, but I'm going to make it a more consistent practice. And I wrote a note down to remind myself to do that, of putting that in the process flow diagram. It's already in the plan, but it's a good idea, I think, to put it here. And I think I'll add that. So this is an example of that. This is another one, a similar, actually exactly the same plant, but it has a different production unit in this plant. And in this one, it's a little, it was better to use more kind of figurative examples of the way the process through, because we're talking about the flow of other materials through here. So it just showing you that even in the same plant, you have something that looks completely different. And in this case, this production unit was it's like combustion processes at the facility, but there's more than one. There's a big giant production process associated with some gas turbines, but then there's other combustion processes that also generate emissions. Go ahead, Pam.
So we're gonna look at your last couple of slides.
Okay,
and
fine.
I really want
Go
to
ahead.
get to your
Okay.
And I see your hand there, Bill, but we're going to complete Maura's presentation.
Okay, so this is just another example, it's very simple. What happens, what happens here is a small process of what goes in and what goes out, but it does the job. There's nothing else that happens in cell operations. And this is easy. And we made this from scratch. This is a much more complicated process. This one really took some time. Oh, this one, I gotta tell you, this was the movement of lead. This facility, takes metal and then they manufacture a set of products from that. But there's a bunch of different products that they matter. But and each one of those products has a different concentration of lead. But they tracked it. They already tracked the amount of finished product from each one of these processes. So we knew exactly how much went into that process. We knew how much went into that process. And then we kept track of the points on this one. On this lower side of the map here. So it just was a completely different process flow diagram. And then it also has another calculation sheet that goes with it that relates to it. So
That's
I
great.
guess the point is that they're all different. And I guess that's where I wanted to get to that. And here's one that's very similar. This one was drawn using the guidance from Turi and Mass DEP, similar to the one that Pam showed earlier. This was the one this year that went through an iterative process. It went back and forth and back and forth. My client on this case said, I don't have any byproduct. Everything goes into the product. I'm like, okay, well, that's good. But then when you start talking, he's understanding, well, we have a little bit that goes out there. And then like, oh, well, we do have some waste product. But it wasn't a process where you're trying to be critical towards the person. You're just saying, just be realistic. It's not, the process is for you to be taking a realistic look at what's happening to help you. And there's no penalty to you for doing that. Just, it's a good process for you. And we got on the same page on that. And we were able to really figure out what really happens here and what goes in and what goes out. So it was a good process for us. So the challenges that I understand from getting the process, it's getting the process steps down and deciding on the number of production units. I think that is, we've had numerous tour sessions on just figuring that out. It's iterative. I'm just saying that each year when you go back and look at that, you're looking at more process steps. Getting the correct information is always a problem for a variety of reasons that may not exist. Number one, it just can't be updated. They don't have enough bodies in the plant. Somebody can't get it. It's all kinds of ways to get that, but you got to figure out ways to get around that and get the best data that you can. You have a challenge of finding a really good reviewer. I love working facilities that look at my stuff and go, you got this all wrong, or you got this is good, or this is not so good. I love that. So finding a really good reviewer is super helpful. Running out of time or rushing the process, I think we all do that. We just run out of time and we have to move the process along quickly, and we're trying not to, but it does happen. So it's a challenge to keep ahead of that curve. I think another challenge is simplifying. I mean, if you're making a process flow diagram or making a process description, you can lose your mind. You can go into a rabbit hole of detail and you think, holy smokes, what am I doing down here? Because you have to remember what the objective is. Your objective is to find a toxic use reduction. You're trying to look for options. So getting more and more data and finding more little steps, if it's not helping you get to toxic use reduction or finding options, then you just have to focus on simplifying. It's finding a balance. I find it difficult. And I have to remind myself that there are going to be changes. There's no doubt about it. No matter what I do, no matter how I get it done, and I think it's done, there's going to be a change. So.
Thank you, Maura.
Yeah.
Thank you so much. So it is 10:30, and I want to recognize that the time for this session was 9 to 10:30. So I'm going to stop recording, and you don't need to leave. We can have more of a conversation.